Hi everybody. This podcast is about increasing and decreasing functions. Again, we're going to be using the value of the function's derivative so we can determine the critical numbers of the function. We're going to use those critical numbers to determine intervals of increasing and decreasing behavior in the function. So the first thing we're going to do is find the critical numbers of the function. And then the second thing we're going to do is set up intervals using those critical numbers. And these intervals are going to be the areas that we will test for increasing and decreasing behavior. After we find the critical numbers and we set up intervals to test, we'll pick a value within each interval and we will test it. By testing it, we're going to take that value and plug it into the derivative. If the answer to the derivative is greater than 0, which would mean a positive answer, then the graph will show increasing behavior. If the derivative with the test value gives us an answer that's less than 0 or negative, then that will mean that the function is decreasing in that interval. And if the function's derivative is tested and it gives us a 0 for an answer, then that means this is a constant and the graph is neither increasing nor decreasing at that time. Likely it would be running flat. Let's start with this function, x to the 4th power minus 2x to the 3rd. If I take the derivative of this function, I get 4x to the 3rd minus 6x squared. And then if I factor that, I get, oh, that looks kind of terrible, doesn't it? Let's just start over there. I get 2x squared times 2x minus 3. If I set both of these equal to 0, then I'm going to get values of critical numbers of x equals 0 and x equals 3/2. I'm going to use these two numbers to set up intervals for which I'm going to check my graph for increasing and decreasing behavior. So the first part of this is to say the graph is going to start at negative infinity on the left-hand side, and I'm going to use that as my beginning. So if I'm going from negative infinity and then the value goes up to where the 0 is, that's my first critical number. And then from 0, it's going to go up to, or down to, we don't know which, right? It's somewhere between these two, 0 and 3/2. And then the third interval is the last part of the graph would go off to positive infinity. Okay. The next thing we're going to do is pick a test value between these two, each of these numbers. So for this one, I'm going to test x equals -1. It falls between negative infinity and 0. I'm going to pick x equals +1 for this interval because it falls between 0 and 3/2, and I'm going to pick x equals +2 for the last interval. Now I'm going to test each of these in the function. I'm sorry, not in the function, in the derivative. So if I have the derivative, I'll take that out of there, and I plug -1 in there, So I'm going to get a negative 4 minus, plus 6. So that would be a positive 2. This would be a positive answer, and so my graph would be increasing. I'm going to plug in positive 1 now to the derivative, and I'm going to get a positive 4 minus 6. That's going to equal a negative 2. Negative solution means my graph is decreasing at this point. I'm going to plug in to my derivative a positive 2. So 2 to the third power is 8 times 4 is 32 minus, I'm going to just write this down here so I don't forget it, 32 minus 2 squared is 4, so minus 24, right? 6 times 4 is 24. So that would be a positive 8. So our answer would be positive. So that would mean the graph is increasing between those intervals. Using the information that we have figured out about the increasing and decreasing of the graph, I'm going to use that along with the critical values that we know, 0, 0, and 3 halves, right? We said critical values at 0 and critical values at 3 halves. And if you evaluate the function at that, you get 0, 0, and so 3 halves would be about here, and that ends up being about negative 1.7, so it's somewhere around here. So these are the 2 points that I know. I'm going to use this information. So from negative infinity to 0, my graph is increasing, and then it turns down, it's decreasing till it hits the 3 halves, and then it is increasing again off into infinity. So this allows us to sketch the graph using just critical values and creating an interval and testing some number within the interval to decide whether or not our values are positive or negative. Whether they're positive or negative determines whether it's an increasing or decreasing behavior in the graph. Let's take a look at this function one more time. I just really want to go over the math part of how to determine the increasing and decreasing. We will take some time to do the graphing part as well, but really this part is what we're focusing on here, is learning the increasing and the decreasing. So I have a function x to the third minus 6x squared plus 15, and I've already taken the derivative, 3x squared minus 12x. I'm going to simplify that or factor that. So I get x minus 4 times 3x. So my critical numbers are x equals 0 and x equals 4. Okay, I set each piece of the product to 0 and solved. These are the numbers that I'm going to use to create my intervals. So I have negative infinity to 0, I have 0 to 4, and I have 4 to positive infinity. So remember that critical numbers are what indicate some sort of extrema in the graph, and so it's indicating that there's some change in direction. So these are the points where the graph would change. Well, it should make sense that if the graph is changing, going into the graph going into this point and away from this point have to be change in increasing and decreasing. So we're going to pick a test point for each of these, and we're going to test it in the derivative. So I'm picking a number that's between negative infinity and 0. So here I'm putting in -1, and I'm going to test it in the derivative. Now I'm picking a number between 0 and +4. I'm going to pick 1, and I'm going to test the derivative over here with a number from in between 4 and +infinity, which I'm going to choose 5. So when I plug these into my derivative, I get the answers of 15, -9, and +25. So this is a positive answer, a negative answer, a positive answer. This means that our graph is increasing in this interval, decreasing in this interval, and then increasing again. This is all we're going to do as far as learning to use the derivative and to determine increasing and decreasing in the graph. We will have another lesson where we talk about how to go about using this to make the graph.